The good news for you is that the mechanics chapter, the mechanics section, is actually the biggest part of the course.
Biggest part?
The biggest part we've just done, the mechanics. All the other sections are smaller than mechanics. So that's good news. Secondly, in my opinion, the mechanics has a lot of difficult English in it. The next chapter we'll do after this is electricity. Not as much English in electricity. Yeah. Mechanics is a very big part of the course because it's a very important part and a very old part of physics. So this is the last mechanics topic we have a look at today, called the pendulum, which you know what a pendulum is because you've used that word this week. Does anyone else know what a pendulum is? You know, yes, very good. Good. So we see this on the grandfather clock, the pendulum. Okay, so there's not a lot to do about this, but here's a picture of our pendulum. Firstly, when we look at a pendulum, we don't consider any mass here. We just have the mass at the bob at the end. Okay, that's the first thing. Secondly, and I think you were asking me about this, the equilibrium is in the middle here. Okay, and also we consider it frictionless, so not damped. Of course, in real life, it will slow down, but for us, we imagine it's not damped and it will smoothly move like this, oscillate. Yeah. So if you can draw this. Well, not quite actually. That picture I see is not that clear. I'm going to draw a picture now in a moment. Yeah, I don't know why they put amplitude beside the angle in the picture. Because the amplitude, of course, is how far out it swings. But we'll discover in a moment that the amplitude is not important for the pendulum. Anyways, can I continue? Yeah? Right. Let's have a look and study this in a bit more detail. So here's the pendulum here. And we'll say it has a length L, and we'll call this angle here theta, and we'll say this has a mass m. There are two forces on the pendulum. What are the two forces on the pendulum?
Gravity.
Gravity, good. So there's an mg here. And also, yeah, well, the circular, well, not quite circular, but tension force in the string. Yeah? We should resolve. So, if I resolve this T, let me get rid of that. Now, actually, you know what? I don't want to use T because I'll need to use T later, so let me use S. Okay. If I resolve my S, here and here. What is this angle? Oh no. Yeah. What's this called? Theta. So what is this force? S cos theta and S sine theta. Now I don't actually care about the S cos theta because all the S cos theta is doing is equaling mg. What is actually causing this to move to the left? This here. This force is causing it to move to the left. So I'm actually very interested in looking at this force because this is where all the action is happening. Right. So we need to work out a formula for cos and for sine. Now, if this is L and that's theta, how big is this side? This is L cos theta. And how big is this distance? That's L sine theta. Yeah? Now, wait, before you write that down, the problem, I don't want to use this, because the real problem I'm having is I have a theta, and I have too many thetas, and I don't know what theta is. And there's also a second problem. What way does this bob move? It doesn't quite move like this, does it? If it did move like that, that would be great. That would be simple harmonic motion, and that would be wonderful. But what is it doing? It's kind of moving like this. It's kind of somewhere in between a circle and simple harmonic motion. So for this problem to continue, we have to approximate. We have to say that we imagine that this moves in a straight line over to here, stops and goes back. Now we all know it doesn't quite do that, but we need to imagine that it does do that. Yeah? If I call this distance here from here to where the pendulum is, I'll call that distance x. And you notice now that x looks like the simple harmonic motion, that it starts in the positive and it goes negative and it goes left and right here. Okay, what is sine theta in this triangle? X over L. Okay, let me use x over L. So if I look at this force here, I have F equals minus S, because it's going to the left, sine theta, which equals minus S x over L. Okay, that's kind of helpful, but I don't know what the S is. But I can get the S from this. The S equals mg over cos theta. Yeah? Now, what is cos theta here? Cos theta will equal this side over L. And how big is this side? Well, this is where it gets a little bit messy, because if it was a straight line, or if it's moving in a circle, we kind of have two different answers. So we kind of have to roughly estimate the answer. This length here, how much is this? That will be the same as that, won't it? But this length here, will it be bigger or smaller than L? A little bit smaller. So what we need to do is we say it's roughly equal to L. Now we all know it's actually a little bit less, but it's close. So what does cos theta here equal? Equals 1. So actually I can get rid of that and change this into minus mg over Lx. Okay, what did Newton say the formula for F is? He said ma. So now we have ma equals minus mg over Lx. Okay, I can cancel and I get a equals minus g over Lx. Now let me just call omega equal to the square root of g over L. I'll just make this replacement. So if I make this replacement, what do I get for the a here? What would this become? This would be minus omega squared x. Now, have we seen this formula before? Yeah, we have. This is the formula for simple harmonic motion. So it is moving in simple harmonic motion. Not only that, I actually can see what the omega is for the problem. If I know what the omega is, I can know what the time is. What's the time? It's 2 pi over omega. So that would be root L over G. And this is the famous formula for the time it takes the pendulum to swing forwards and back. We only need to know how long the pendulum is, and we can know how long it will take to swing forward and back. This is the proof of this formula. Now you don't need the proof for the exam, but you will have to do an experiment on this in the second semester. So it might be useful to write the proof down, because you might need it in the next semester. Yeah?
What's with the negative sign? negative s sine theta.
I put the minus in because,
No, I mean like that. How did you get s sine theta?
I resolved the s force into a sine and a cos in the diagram.
Oh yeah.
And I only care about the sine, because that's what's making the interest in motion. The only purpose of the cos is to cancel the mg.
Why only like to smooth
Well, if you're not happy with that, let me just do it this way instead. If I go backwards a little bit. Are you happy up to here?
Yeah.
Okay, so I can rewrite this as G over L equals minus A over X. Are you happy with that? Okay, now, because this is simple harmonic motion, you know that A equals minus omega squared X. So you can say that minus A over X equals omega squared. True?
Yeah.
But minus A over X is equal to G over L. So it must be that the omega is root G over L. So that means the T is 2 pi root L over G. Yeah? Yeah? Well, look, it's not absolutely necessary to have this proof. Okay, it's not on the exam. You don't absolutely need it to do the lab next semester. It's nice to have it in your notebook, but if you don't have it, or if you want to write it down later from the video, that's fine. I wouldn't really be stressing about this.
How did you get the MGO? Negative sine x over time.
More space for people to walk by. Okay? Not okay. Are we just waiting for you because, you're not Bruce. I would wait for Bruce, but, no, I'm waiting for more than one person.
That's what G over L.
Ah, that's what he asked me. So, were you unhappy with my answer, or you missed my answer? Ah, okay. Okay. Now where do I start? I'll start here. Are you happy how I got to here? Okay, so we're good with this. Alright, so forget about this and just on the side, you know that this is simple harmonic motion. you know this formula, true? So, can we rearrange this formula to make this formula? Yeah. So you're happy with me saying omega squared is minus a over x. Okay, keep that in your mind. If I go back to this problem here, here, I can just rearrange this so I get g over L equals minus a over x. But I know what minus a over x is. According to this formula, minus a over x is omega squared. Therefore, the g over L must be omega squared. And so omega must be root g over L, which leads us to the t here. Yeah? Continue? No. What are you writing actually? Where are you? Not my phone. Your phone? Your phone. Okay, do you have that? Yeah? Okay, continuing now. So, let's have a look. How long would it take a 1 meter pendulum to swing 10 times? Calculate this for me using the new formula. Oh yeah, you really need the plastic for this one. We're still talking about KFC, huh? Yeah, where did your staple go? You must be very rough with this book now. You need to be gentle with it, okay? It's a sacred book, okay?
Put it there.
How many physics classes do we have tomorrow, or is it just one?
Two.
Yeah,
One.
One assessment support, yeah.
Yeah.
We should get to that one, yeah.
Yeah, but
That's all?
no, I'm just thinking, how far are you in your homework questions? Because you have circle, simple harmonic motion, and pendulum. What we can do tomorrow for the tutorial, what I think I'll do is we'll have 2 tutorials. So what I mean by that is tutorial tomorrow, and then the first physics class next week will be a tutorial as well. So what I would like is tomorrow to give you some time to finish these questions in class and then finish them on the weekend. Once you have all your mechanics questions finished, then when we are back in class next week, we can review what questions were a problem. Okay? But I want to make sure everything in mechanics that you had trouble with, we cover it. So we'll have a tutorial tomorrow and next week, and the assessment support tomorrow. Just before I talk about the assessment support, what answer did we get here? 20, about 20 seconds. Yeah. Okay. Yeah. That's right, yeah. Multiply your answer by 10. Okay, not this. Yeah, we'll continue. I'll let you work on these for a few minutes, but just before I do, has everybody submitted their sources onto Moodle?
Should be correct.
If you want more marks.
No, like should be correct and answer them.
Yes, you can. Yeah. I have the quiz open so you can resubmit, I think. Yeah, everybody, some of you probably noticed that you got feedback on your links that you submitted. No, you didn't notice this? You noticed this. So some of the links you sent, I said, were okay, and some of them not okay. What?
I have changed some things.
That's fine. That's why we're doing this.
Okay.
There was one which is said like 404, but then it was I didn't want to send that link, but what I wanted to send was the slide, but then I couldn't put the slide into the Moodle, so
Well, I see. This is a problem though. So if you give a link in your in your essay, then it should be possible for anybody to follow that link and get to the same information that you had.
on the slide.
Yeah. So if you can't find a link to get the slides, then
But the slide has to be downloaded.
but that's fine. Just get the link to download the slides. Just make it accessible. You know, where did you retrieve it from? You can work on these questions for a few minutes, but for tomorrow, I'll just remind you now to bring your laptop.
Tomorrow.
Yeah. For assessment support. And I think tomorrow, it would be really great if you can have all your sources ready for tomorrow. But don't worry, you can change your sources later. The purpose of giving me the sources now is so that you can understand what type of things are okay and what are not okay. So if you want to change your sources later, add more, that's fine. Because you should figure out what will pass the test and what will not. Yeah? Because I noticed that some people had good sources, but they were too advanced. Yeah? And some people had like links for like BBC, and that was okay, or you know, stuff like this. Tomorrow I think maybe we'll work on. I think tomorrow what we'll do is we'll work on making a plan for the essay. So, how many paragraphs, what should be in each paragraph, and so on. Yeah? Where's your feedback? You have to go into the quiz. Oh, maybe I didn't maybe I didn't correct yours yet. Can I see? Yeah, I didn't correct yours yet. No, I didn't correct everybody's. I corrected maybe about 4 or 5 people so far. So I'll do this later today. At a quick glance, they look okay. Maybe some of them are too advanced. I'll have to check. Yep. Okay, try these questions for a few minutes. Can I close this? Yep.